Okay, good morning, folks. This is Tim. I hope you're doing well this morning to the 22nd of October, 2025. We have Melissa out here. There's been some changes overnight. Um, I hope y'all doing well this morning. And we wake up to this, some changes overnight to this system here. Um, Yesterday, the low level center had kind of moved out underneath this canopy of higher convection due to westerly shear. It appears, at least right now, that the shear is less than it was yesterday, and I'll show you that here in a second. But looks a lot more. I mean, it's still sheared some from the west, right? And the low level center is probably somewhere in here. We may be able to get a better look at it with the true color, maybe natural. No. Um, you can see there's still a sharp line on the western fringe here, although the cirrus canopy is expanding outward. So, and you can see these clouds kind of moving generally this way a little bit. But anyway, this is the mid-level water vapor loop showing a lot of blowable convection this morning. Probably due to the diurnal cycle. Overnight tends to be the most active intensification wise when these cyclones are getting going. We'll get into the complex discussion about why that happens, but that's sometimes what happens here with cyclones. You get a big blow of convection overnight. During the day there's a diurnal minimum where it's not as much, but um, either way, yesterday I was looking at this system, and the low level center had raced out ahead of it out of the convection, but looking like this morning it's not that way. So interesting to see. Uh, so this is what I'm talking about here. This is an analysis of the 24-hour shear tendency. Okay, and here's Melissa down here. All right, and see you see the shear tendency has gotten less in the past 24 hours, almost 10. Either it's 10 knots or let's see, knots. Yeah. So it's been decreasing in the past 24 hours. Excuse me. So that's likely because there's a mid-level high pressure building in this area here, and the upper level flow is kind of being pushed up this way some. And um, so you can see the higher shear values in the reds here. Um, Tendency. Okay. So another thing to look at with this is actual wind shear. See where Melissa is generally this area, maybe 20 knots or 10 knots. When you can see the upper level or mid level high down here in the Southern Caribbean Sea. Okay. So, and there's some divergence aloft here as well because of this. You can see the wind spreading out a little bit this way, right over top of it. So that's helping. See how they're spreading out. That's helping to create um, when you have divergence aloft, it allows for convection to fire at the surface. You have a void that's created aloft, let's just say, and so that allows lower pressure to move to higher. I don't know how to explain it in the right way here, but divergence aloft can lead to um, enhanced convection and allows a cyclone to vent, tropical cyclone to vent its energy outward here. That's what's happening here. So interesting what's going on there. Not to say that it's still not going to be impacted by shear. It is, but it's not 25, 30 knots right now. So yesterday it was pretty unfavorable. So it's maybe in a neutral to somewhat favorable environment right now, given the divergence aloft as well. When you have convergence at the surface, divergence aloft, that helps get a system going here. So when we look at let's look at upper divergence. You see where the upper divergence is here in the yellows. That's what I was talking about. All right, that value of 40 right over the system here. So in lower convergence, we have convergence around the system as well, which helps when you have convergence at the surface, divergence aloft. You tend to get lower pressure to form at the surface, all other conditions being equal, right? Vorticity. And well, that's a good explanation anyway. I don't know if I can explain it right, but that's the gist of it anyway. Sorry to get in the weeds there, but so one other thing to look at here, we can look at 850 millibar vorticity, which is closer to the surface, and this will help us look and see whether it's tilted from low to high, like from a lower level perspective to the surface to up and higher in the atmosphere. See the 925, 850 millibars. 925 is closer to the surface. 850 is a little bit higher. 700, you see the 700 millibar vorticity is further west, further east, excuse me. And then the 500 is even further to the east. So that tells me it's still tilted with height, um, which will limit um, rapid intensification, at least at this point. Although I think it's at some point it's going to be able to intensify. So that's a little bit of explanation about that. Uh, so hope that helps, and I hope I didn't confuse people with divergence and convergence. Again, convergence at the surface, divergence aloft is good for cyclone development, intensification. If you have all other factors like sea surface temps, midlife humidity values, other things like that. There's a lot of things that go into it, but that's the gist of it. So, what's the latest from National Hurricane Center? 50-mile-per-hour tropical storm moving to the west at 12 miles per hour. Slowed down a lot since yesterday. So, this is the latest track and intensity guidance as of 8 p.m. Well, sorry, 2 a.m. this morning. There'll be another update at 5 a.m. I'll try to catch that and put that in the video in a few minutes. Um, Here are the key messages. The track cone is shifted to the west here now. The official track wants to take it right over Jamaica um, next Saturday, this Saturday, sorry. Today's Wednesday. Uh, I think we'll be dealing with this longer than that. We'll see. Here's the latest Melissa model track guidance. The GFS and some of its partners in crime here still want to take it on a sharp right turn, which I really don't think is a plausible scenario at this point, unless this becomes a much stronger system in a short period of time. It's probably still going to feel the not to be vertically coherent enough to feel the upper level flow to the north here. So it'll likely move generally to the west or west northwest for quite some time, maybe meander around in this area. And if some of these models are to be believed, become a very intense Cat 5 hurricane. So I'll show you all the models next, and you'll see what I'm talking about. I hope this doesn't happen. Right. First, I'm going to go over the ensemble guidance, and this is the GFS ensembles, right? This is starting Friday. Pretty tightly clustered going into Friday. You see a lot of members just to the south, east of Jamaica, Dominican Republic. A lot of divergence at this point. And what's interesting is even though the operational run takes it out to the north, a lot of its members are now moving into the west more. So, of course, they eventually move out to the west. And what you see here, I think, is a totally different system here. I'm not sure if this is Melissa or not. I have to look at the operational guidance, but it leaves some vorticity behind, it looks like, and it wants to bring another system through there. I don't know if that's Melissa or not. Weird. Um, let's see. This is the Canadian ensemble. A few members move out to the north here, but most of them go. There's a wide range of possibilities here. So anybody in this Western Caribbean Sea needs to, even the Bahamas, Turks and Caicos needs to keep an eye on this thing. European ensembles. This is, let me see if I have a more recent run. There we go. All right. So, European ensembles, you can see squarely in the Southern Caribbean Sea here, which is not good because if it gets in this area, likely we will intensify pretty rapidly, I think, and then maybe move over Cuba, Jamaica, and then eventually out to sea. So lots of scenarios here. What's the Google DeepMind say? Well, here's the WeatherNet experimental model from the DeepMind. This has the wind speed colors. Of course, the higher, brighter colors like are more intense, right? And these are the western movers. I'm going to go through each ensemble here. Let's make it a Cat 3 hurricane. and swing it out through Jamaica, but you can see there's a wide range of possibilities here, you know. And if you look at the cone related to it, take the tracks off. Quite a bit of uncertainty here. All right, all the little dots indicate where it could go. So, Cat 3 hurricane. So, with the next gen model, another Google DeepMind Ensemble. Takes it further to the west, but still wants to take it over Jamaica. Lots of uncertainty. You can see how many different models are all over the place. You can see how large the cone is here. um, with the next graph model, doesn't really have an ensemble. But you see here wants to take it. When we put the ECWM, the European, this was initialized at 1800. That's the latest we got. So that's as far as it goes. My screen is glitching out here, so hopefully this doesn't show up in my video. It looks kind of funky right now. Sometimes it does this. So what's steering this thing? When we look at the European ensemble here, not the European ensemble, the European operational run. If we initialize this at 00Z, which is a few hours ago, you could see the A50 vortex here, 500 millibar height to the west of it, which we showed on the other analysis with the 500 millibar mid-level circulation is displaced from the lower level circulation, right? And we have the 500 millibar heights are indicated by these lines here, which is that. And you have 850 millibar vorticity here, which is a good representation of the surface for the most part, okay, in this case. So what's steering this thing? Initially, it's steering by low-level winds, right? Because it's not vertically aligned. Low-level winds are quite chaotic. It doesn't show low-level winds here, but trust me, the low-level winds are it's very chaotic in this area. Okay, not a lot of steering currents, and you see what happens here. It becomes vertically aligned. A trough digging in along the eastern U.S. Okay. Really becomes vertically aligned here. That flow, the mid levels, increasing out this way enough just to feel that flow, right? And that's where it takes it. All right. And this comes to pass. It might have a very deep, well, if this interacts with this enough, it could potentially, if it gets close enough, it could potentially pull it in, but it doesn't look like this is going to happen. It's just going to be absorbed into the mean flow. I have to zoom out here and look. Let's look, see what happens to it. Very deep trough here on the East Coast. Slings the energy up into the Atlantic Canada and gets absorbed into that system up there. And that's first of the month. So as a scenario for the year, what the European is doing with it right now. Okay, so moving on, I wanted to go through the hurricane model guidance here, which frankly scares the crap out of me because I hope this doesn't happen. But all the hurricane model guidance agrees this becoming a very intense system in the southern south central Caribbean Sea. You can make, this is a zoomed in view, but you can make out Jamaica here. Okay, very intense. I hope this doesn't happen, guys. Okay, H-Worth hurricane model, um, October 27th, showing a very intense, arguably Cat 4, close to a Cat 5 hurricane here, just south of Cuba. Trying to see this here. Kind of goes between Jamaica. Interesting. Jamaica and Dominican Republic. Interesting track there. But uh this has a hurricane model, right? This is one of the hurricane models designed specifically for this purpose to uh it's designed for hurricanes. So this is an infrared satellite representation of what it thinks Melissa would look like south of Jamaica. It doesn't have the pressures here, but you can see the eye, very symmetrical, super intense. And if we go to the radar MSP, 901 millibars, which is a Cat 5 hurricane, okay, south of Jamaica. HASB is even worse. Further west, in this, in it moves it further west, 886 millibars. I mean, I that would be incredible. I think this is on the extreme side of what could happen. This is close to the lowest pressure I think ever observed if this happens in the Atlantic. Okay, so not likely to get this low. All the conditions have to be perfect for this to happen. So this is the Your AI model operational run. I want to show you this. It still wants to take this over Jamaica, and it's usually pretty conservative, and it even makes it into a Cat 1 or 2 hurricane, moves out to sea pretty quickly, which I'm not certain that this is a valid scenario. Okay, this moving out so quick. 28th. We'll see. Um, this is a European operational run. Initialized 23rd, hangs it around Caribbean Sea, never makes it to Jamaica, although it's hanging around right nearby, intensifies it into a arguably Cat 4 or 5 hurricane south of Cuba, moves it out to sea, interacts with that trough, and moves up the coast. Your AI model, I think I already showed this, but there it is again. GFS, take a look at it. I I just don't think this scenario is going to play out, guys. We'll probably see it shift further to the west the next run. Canadian is one of the extreme west models, although it doesn't intensify that much here south of the Jamaica like the other ones do, but it puts it right off the coast of Mexico, and it still ends up being about the same as far as track goes. Intensifies it into a hurricane, Cat 1 or 2, maybe Cat 3. Icon, it was a west outlier till recently, and now it wants to move it between over Jamaica and then over to the western part of Cuba. Wow. Well, that's a lot to chew on, isn't it? As a meteorologist, I have to say this: as a meteorologist, I really like seeing and watching this stuff, and I like talking about it, but I don't like to see the carnage that may become of this if it does hit land. Um, one thing I know for sure, there's going to be a lot of rainfall going on in the Caribbean as a result of this. Nothing else, there'll be catastrophic flooding wherever it comes near to a landmass. Future intensity is always notoriously hard to predict, especially super intense hurricanes. Okay, all the conditions have to be perfect for it to happen, and you know that is what it is. We just got to watch it, see what track it takes. The longer it stays over water, I think the better chance it has of becoming more intense. And stay tuned, guys. If anybody is listening from the Caribbean islands, which you're probably not, but I would pay attention to what's going on. You should be already. It's still hurricane season, so y'all be safe out there, and God bless.